Hi, everyone, and welcome to the session on health management. Our first presenter is Marno Du Plessis from Discovery. It was all yours.
We're all familiar with call center experiences, and some of this you might remember if you attended my talk yesterday. And if you think back to your own experiences with phoning into call centers and you think about speaking with call center agents, chances are you can remember some instances where you've had this really comfortable, natural conversations with the agent. You felt you understood each other, it was quite natural. And chances are maybe you can recall some experiences where you did not really have what we can call an affinity with this person on the other end of the line. And yeah, if we can rather not have those kinds of experiences, that's definitely what we want. So for us at Discovery, and then specifically Discovery Health, if we consider the scale at which we operate, if we've got up to 20,000 just members phoning us each and every day, and we have 1,500 call center agents, we really want you as a member to have the best quality interaction. So we can make sure that we can assign agents to calls to maximize those affinities or quality of interactions. That's what we want to pursue. And in this talk, I'll share a bit about that. So I'll give you just some background on this concept of what we call affinity matching and its application at our business. I'll tell you a bit about our initial affinity matching design, and then I'll update you on what is our new design that we are implementing now. Also share some of the challenges that we've encountered surrounding the implementation, giving you some more of the practical insights into how you implement such a model in a business environment. And similarly share some of the lessons that we've encountered and hopefully some tips and tricks for you to keep in your back pocket for the future. And again, just telling you a bit more about where we are going with the future of this project. So this concept of affinity matching, we've introduced that first in the business in 2015, and quite simply what we do with affinity matching, or how we define it, is to say that when we want to match a member phoning in to a certain call center agent with whom he or she is most likely to have the best experience. So we apply this concept of affinity matching across various domains. So for example, on inbound member servicing calls, so a servicing call would be just if a member phones in, want to check in on the progress of a claim or want to change banking details, servicing call. But then also when it comes to what we call conservation calls, is if a member would indicate that they would like to lapse their policy, we have a dedicated team that could phone them and try and retain these policies on the call. We've also got affinity matching implemented in this kind of team or department. So just as an example, if we've got member George right here and agent Alice, we believe they would have the best affinity with one another. So if George phones in, we are going to see, but at the first attempt, we're going to try and see, is Alice available? And we're going to try and assign Alice to George on this call. In this talk, I'll focus on our affinity matching for members, and this is specifically applied to our Discovery Health Medical Scheme members, or DHMS for short, on these inbound servicing calls. And the requirement we have then is the member needs to verify his or her identity up front in the IVR system, that automated system you encounter at first when you phone into the call center. So of course, if we know who you are, then we can match you to certain agents. And the quality of an interaction then is currently measured by what is customer survey, which we call MBR. So some background on MBR. It stands for member-based research, and it is this customer survey that we send to some callers after they have had an interaction with us. And you'll get an email, look something like this. And we ask you to rate the quality of this interaction, importantly with the agent, on a scale from 1 to 10. And we would send this then to a random sample of callers. And to gauge the impact or efficiency of affinity matching, we would compare this MBR of affinity calls to non-affinity calls. A non-affinity call would be a call where the member did not verify his or her identity, or maybe it's a new member and he or she is not yet part of the model. Those would be the non-affinity calls. And we can compare this, and if the affinity calls track higher in terms of MBR, then that would suggest affinity matching being successful. But of course, there could be many other factors also influencing MBR. So in our business, there's many different initiatives geared towards improving MBR, and I'll share a bit about how difficult that really is to achieve. But yeah, so something like training of an agent, that could also have a huge impact, but I believe that affinity matching is arguably one of the main influences of MBR. I've mentioned this initial design that we started with 7 years ago. And just the premise of this design is to say that we start with our call center agents, and we've got 1,500 of them in Discovery Health, and we would divide them into different clusters based on specific sets of factors. So we've got the different clusters all based on certain features. And then for each member, we would run a model where we match or analyze rather these kinds of members based on certain features. What was the experience that these members would have with these different clusters? And then we find what are the most predictive factors of the likelihood of perfect MBR. So perfect MBR would be a 10 out of 10 score. And then, for example, something like age and the kind of health plan you are on, we found is some of the most predictive factors here. And then ultimately you get a ranking of these clusters for every member. So when this member here would phone in, let's say the ranking is from top to bottom, we would first consider cluster D and try and assign an agent from cluster D if he or she is available and of the right skill. So importantly, when you phone in, you have a particular kind of query, and there's a dedicated pool of agents to deal with this kind of query. So obviously we can only assign agents trained for that particular query. So that's the premise of what we would call affinity matching 1.0. So if we evaluate this version 1.0, know that it is on this cluster-based level. So let's say, for example, in a cluster, there are 200 agents. There's still considerable variation in terms of which agent you may be assigned to. And we can say it's not really affinity on an individual level. It's only based on this likelihood of the perfect MBR, so not necessarily considering the whole domain of MBR scores from 1 to 10. And the features are relatively static. So, for example, a health plan code, scheme plan is unlikely to change quite frequently. And then this particular model was also executed on a manual basis, and the reporting was done manually. This consumed a whole lot of time. If we fast forward to this year, or where we are now in the business, is we have much more mature operations and servicing data assets available compared to previous years. And we've got this established infrastructure for model automation. And what we said is, let's take this opportunity to now add much more sophisticated features and really enhance this version 1.0. And this led then to the birth of Affinity Matching 2.0. The premise of Affinity Matching 2.0 would be to predict the MBR for every member or possible member-agent combination. So what we say is we take all our members, all of our call center agents, and let's predict the MBR score for every possible combination of if a member would speak to an agent. So this means we do away with clusters, and we add much more granular or time-dependent features. So, for example, considering recent call and email interactions load from a member sentiment, on the agent side, considering factors such as agent performance. And then we said, of course, a definite goal or outcome of this model would need to be to automate the execution and reporting of this model. So just to be clear then on how this would work is we've got our member again here, and then we've got rankings from member to individual agents. So if we say these are the predicted MBR scores here on the right-hand side, and then this is the ranking. So when a member phones in, we're going to try and assign agent rank 1 going down this ranking list. Again, only if this agent is of the right skill required by this kind of call. So now I just want to give you an idea of, if you build this model, how exactly do we implement it, or what's the real workflow or pipeline in a business such as ours. And if we start here from the left-hand side, is we start with our production database, so SQL Server database, from which we would extract these member and agent features and our historical MBR data. We're using an XGBoost model to then predict these MBR scores. And then once the model is trained, we can now use it and predict MBR scores for our members as if, let's say, they're calling today or tomorrow and such. And all of this is done in what we call a model execution framework, which is just our in-house platform for where we would automate models. And when we get all of this output on the prediction side, we store this on a specific data warehouse. And then when a member would call in, as I've said, he or she would need to verify his or her identity so we know who it is. Then via a web service application, we can go and query this particular member's ID, and we can extract the ranking list for this particular member. And all of this is done by our Genesis platform or telephony system that we employ. And this Genesis system would then go and filter which agents are available at this time of call. And then, of course, if they are of the right skill as well. Just some notes on the model training and complexities over here. So if we look at the distribution of MBR scores in the training set, or maybe more broadly just in the business, I mean, thankfully, we do get many 10s out of 10s, but because the volumes are really only at the 10 out of 10s, it makes it difficult to really predict accurately for the lowest scores. And this year to date, we set an average MBR of 9.02 in the business. So it's incredibly hard if you work off such a high base, and to move the needle of MBR by even 0.1 is really difficult to do at this scale. But then if we do this predictions then, and we look at the results of our test set, then what I want to highlight here is that we still have this linear trend of at least predicting higher MBRs for the higher scores. And of course, then we still get it right where we do have the volumes, but it becomes much harder as we go down. But nonetheless, when we produce this ranking list, then this is what we go on when we assign the ranks for an agent to each member. So just to make it concrete, what does this output really look like? So if we've got our database table over here, member ID for each agent ID, predicted MBR value, and then just a numeric value assigning the rank then from 1 to approximately 1,500, because that is how many agents we would have per member. So we are yet to go live with this model. It will happen soon enough, but just to demonstrate this potential improvement in MBR that we may expect. So there was a call where a member spoke to an randomly allocated agent, and this call we received an MBR of 2. Now, if we run affinity matching 2.0, then we can see that this agent that was assigned to this call then was actually rank 992nd, so sitting around here. If we now plot the distribution of predicted MBR scores for this particular member across our whole call center agent base, so you can see this flat line, of course, over here. But then what we see over here is this cluster of 600 potentially better suited agents that this member might have spoken to if we implemented this new version. And of course, not all 600 would be available and of the right skill at that point in time, but certainly some proportion of them would be. Similar kind of plot if we take a random sample of 20 actual calls. And here we plot the difference between the predicted MBR values for that agent that the member actually spoken to, compared to the predicted MBR of the rank 1 agent for this particular member. And you can see varying degrees of difference here. But again, it's always in the upward direction. And this is why we are excited about the potential of this model being able to boost our MBRs. Now, some of the implementation challenges we've encountered, and maybe you might have anticipated this, but it's largely to do with the data volumes. So if we consider almost 3 million members and 1,500 agents, and you think we're going to predict for each possible combination, then you get around 5 billion rows of data. And in our case, that's really tractable, really difficult to work with. So when we tested working with this data, then prediction time would take up to 4 hours, which maybe you can deal with. But writing to the database initially took up to 3 days, and that is not something you can really do or dare to do. And routing the system experienced memory issues under load, so having to pass through all of those data and the memory. And another bit of a drawback would be that there's a lack of integration with the workforce management system. What this means, it's Genesis workforce management system that would sort of manage the availability of agents, so the scheduling, the different shifts, when they're on breaks, when they are available and when not. So if we don't integrate with that, then we sort of still have to predict on all agents, even though we actually might have known that not all of them are available. Potential solutions, so let's say this current configuration, we have actually already upgraded our routing hardware to alleviate those memory issues. But then naturally, if we can reduce the size of the model output, then it's already a big win. So what we said we can do is let's predict only on members who interact with us regularly, because we know there's a large fraction of the member base who don't interact with us at all. And maybe we can truncate it to say, let's only store the top 500 agents per member. And if it's the case that not all 500 are available, maybe assign randomly after that. So that's one configuration. But then another possibility for us is to say, but let's look at what we call live model execution. So this would be to host this affinity matching model on what we can call the Genesis server. And we predict the MBR then in real time as the call comes in. So this is the advantage of no need for storing any predictions. So you're not even having to, let's say, store 1 million rows. You can use much more recent data in the predictions, because currently the configuration would be, say, predict on a weekly basis only. And we can integrate with this workforce management, so we can only consider the agents at that very time of the call that are available and of the right skill. The drawbacks, however, are that this would necessitate a whole different design. So it's not something that the model we have at the moment we can just transfer onto this Genesis server, and it would still be something that we would need to test, because we're talking about milliseconds here, and we would have to test this before we know if it can really works, but it's arguably a much more appealing solution compared to what we have right now. I want to share just some lessons learned, and I want to actually do it from the perspective of me being a relatively recent graduate, and these are the things that you aren't learned in university. So just some of the practical things that we can say we've learned. It's not to say that we didn't do it at all or do it wrongly, but I hope I can share it with you, and it's hopefully something you can learn from and employ in your own organization. So if we look at project management, quite important to gather all the technical requirements up front and get your sign-off from all the stakeholders, so you have that buy-in right up front. Document everything and anything related to the project, the execution, meetings, minutes, notes, and if you have it on a shared space, everyone can contribute, everyone has sight of it, and then naturally have these regular check-in meetings with the stakeholders to make sure you're all still on the same page. Specifically for us, when a model needs to be automated, it's much better or more efficient if you build it as a package. So it was the first time I've done or built something like a package. So important to write your tests in this package, test small scale, build iteratively. But importantly, if we've got a model, then we don't just have the model stop there. It is something that you would continuously have to monitor and keep in mind, what if I have to make changes or enhancements to this model in the future? So if you've got a generic pipeline of functions that you can use in the future to, let's say, add or change features, that makes it much more valuable. And it's important to monitor the drift or potential drift of your features going forward to make sure that your model still performs the same as it did originally, or how you would hope it needs to perform. When coding, of course, documentation, always important. Using version control, and important point here is for us as data scientists, we're not always that close to the actual business processes or what would really generate the data. So quite important to validate your SQL code with the subject matter experts who actually do know where this data come from, so that you know what you're looking at is what you expect shortly. So just automation. If for us, we as data scientists, we built a model, but then we have to hand it over to a dedicated team to automate this model. It's important to know who they are, what platforms they use, because it's not always compatible with one another. So to make sure that you develop in something like a Docker that allows us compatibility across platforms, we found is also hugely valuable to us. So this affinity model, as I've mentioned, will go live quite soon. But there's always tweaks you can make to the model, and maybe on a training side, looking at things like resampling techniques. But yeah, just for other affinity matching models, we'll soon start to develop one specifically for financial advisors. And then we would like to actively pursue this live model execution solution. And then, since we have so many different affinity matching models in the business, if we can build some generic framework or almost a skeleton to work from, and you can just plug in your own requirements into that, will also be hugely valuable to this business. Thank you. I hope to have some affinities with you all for this.
Questions?
There's no mic. Okay. First of all, thank you for this presentation. I found it quite insightful. I do have two questions, just that I hope you could help me with the conceptualization of this problem itself. I don't know if you can go back to that slide where you showed the histogram of the MBR scores. I saw there's a slight bimodality in the density over there. If you were to plot it over there. So just practically, I'm wondering what happens to the lower score people. You know, are they being fired or being thrown into a volcano to put off the station? Just possibly.
So there will be conversations with us from the team leader in a particular team to just follow up on a specific call. I mean, we do audits on calls, so and then maybe just have a look at your training. Yes, I mean, it's not to say that the one guy who has a 2 always gets 2, so it's just aggregated. It's maybe one bad apple in a very good tree. Practically, there are some things to try and make sure that we don't consistently get that.
But that would mean that there's, well, if you look at your y-axis, there's quite a few relative to the other buckets over there of people scoring 1.
Yeah, so
one person.
Yeah, no, fair. But I think in a way, I want to say it's quite. I mean, in a way, it's subjective. How do you really rate this interaction? And people would either gravitate towards just a perfect one or a very imperfect one. Like, what's really the difference between a 3 and a 4?
Does that not highlight some fundamental problem with the scoring mechanism? Because maybe the people are very frustrated with the whole setup of calls, and then just gravitate, just give me 1. And then we're assuming that that's an objective measure of the call center. So perhaps differently put, what happens to these scores, on these sides? What actions are they driving from the business side?
So I don't necessarily know all the detail, but we can afterwards have some chats with my colleagues as well who might know better. But I think it does come to some of these. There's some different interventions we would do on those who get those. I'm not too familiar with the exact details of it.
My last question, then I suppose it ties into this one. On your last slide, you mentioned the need to go and predict MBR scores in real time. So I'm struggling to understand why would one want to do that? Is it to push someone into the volcano ahead of time? What?
So if you're going to call in, let's say you're on a call in, and technically we would have a list of 1,500 agents with MBRs we've predicted for you talking to each and every agent. Now, as I've said, currently we have to do that, and that gets us to billions of rows of data, and we can't store that beforehand. So if we do this now in real time, as you call in, we would do 1,500 odd predictions real time. We don't have to store that at all at scale, because we only do it for that split second that we have to assign you to an agent. We already filter that to the set of agents only available at that point in time, and then we can assign that agent to you.
So it's the predictions over here are used in assigning the best call agent that matches to your profile.
Yes, exactly.
Okay. Now that makes sense. Okay.
Are the agents paid according to how many calls they receive. So agents that perform better will obviously receive far more calls due to their rating being higher in many customers.
So they are not paid by number of calls that they receive at all. I mean, it's something that we'll actively look into, that it could be the case that the high performing agents get assigned higher, but I mean, at any given time, they will be engaged in a call, so we would naturally have to go further down the ranking list, and ultimately it will still be spread. But it is a case that we don't, we need to make sure that that doesn't happen disproportionately.
To that end, the guys with the lowest scores will always get fewer calls. And they'll never be able to pick their rating up if they constantly fail. That's the one bias, but there's one scores. I think it's very helpful. But I also think, I mean, as a discovery client, if I've had a poor experience on my call, I never get to the end, or I probably end it, and I never take the survey. So you're missing a whole cluster of irate customers who actually don't. So, yeah, but for the information you have, I think it's a great tool.
So I just want to say that it's not to say that a lower the MBR value counts for all 3 million members. You will have higher values for some and lower for others. And then, I mean, we've got other ways as well to measure your sentiment or perception of it all. Of course, not on all, but if we do it on a large enough sample, we hope to catch most cases. But thanks for your point.
As to add on, do we add our complaints to you for all?
On that note, grab him for coffee if you want to complain. Thank you very much for the talk.
Han gee dit, maar
Let's give some.
sy gee dit nogal maklik. Ek vra my net
That's due to danger with these ones.
wie dis nou.
Sorry for that.
Ja, okay.
If all the missing
So that
do take
but that will happen.
That's the same.
Okay, so you said,
I see.
yeah, you said it, 100%. Yeah. So my comment is,
Please get to
We're so used to email. It's kind of jarring.
What, you have a minute? Look at this. Oh. Oh. Wat is zo? Want niemand weet wat jij weet. Pretty shaky education.
So our next session is presented by Theresa Viljoen from Stellenbosch University. So, floor is all yours.
Seker vir die van julle wat my nou nie ken nie, ek wil net so 'n bietjie agtergrond gee. Ek was vir 11 jaar in die onderwys en toe het ek by die onderwysdepartement aansoek gedoen vir studieverlof en toe het ek by operasionele navorsing uitgekom. So dit waar ek nou praat is iets wat my baie na in die hart lê. Ek gaan begin om vir julle net 'n bietjie agtergrond te gee van hoe lyk ons onderwysstelsel. Suid-Afrika se onderwysstelsel is een van uiterstes. Ons het skole met die beste hulpbronne en infrastruktuur, soos daar aan die regterkant. En dit kontrasteer sterk teenoor skole met kadige hulpbronne en gebrekkige infrastruktuur. Skole met uitsonderlike onderrig wat baie goed vergelyk met die beste ter wêreld, staan teenoor klaskamers waar onderrig op sy beste sinoniem is met lees uit 'n stel notas of 'n handboek indien 'n onderwyser enigstens teenwoordig is. En hierdie lys van uiteenlopende houdings en omstandighede en ervarings beskryf wat sigbaar is in die onderwyslandskap in Suid-Afrika en weerspreek die visie van die onderwysdepartement wat kwaliteit onderrig vir elke kind in elke klaskamer in elke skool in die provinsie verseker. Nou, alle leerders in Suid-Afrika het 'n grondwetlike reg om 'n publieke skool by te woon en is skoolpligtig vanaf die eerste dag van die skooljaar waarin 'n leerder 7 jaar oud word, tot die laaste dag van die skooljaar waarin 'n leerder die ouderdom van 15 of graad 9 bereik, afhangende van watter gebeurtenis eers voorkom. En dan onderrig in Suid-Afrika geskied in 3 fases. Die eerste fase is die algemene onderwys en opleidingsfase. En daardie fase kan dan in 3 fases onderverdeel word. Hierdie fase strek van graad R tot graad 9 en dit is ook die enigste verpligte fase. En dan leerders wat hierdie fase suksesvol voltooi, ontvang dan 'n AOO sertifikaat wat dan staan vir algemene onderwys en opleiding, wat 'n vlak 1 kwalifikasie is volgens die nasionale kwalifikasieraamwerk. Die tweede fase is dan die verdere onderwys en opleidingsfase, wat strek van graad 10 tot 12. Hierdie fase word dan ook aangebied by tersiêre colleges en fokus op loopbaangerigte onderrig en opleiding. Die bestuur van die eerste 2 fases is dan die verantwoordelikheid van die departement vir basiese onderwys en die derde fase is die hoër onderwys en opleidingsfase wat dan deur tersiêre instansies behartig word. Nou, publieke skole in Suid-Afrika word deur die departement vir basiese onderwys in sosio-ekonomiese kwintiele verdeel. Nou, die kwintielrangorde stelsel is 'n armoede-indeks wat die departement vir befondingsdoeleindes gebruik en dit word bepaal deur die inkomste, geletterdheid en werkloosheidssyfer van die gemeenskap rondom die skool. Nou, kwintiel 1 verteenwoordig die armste skole, terwyl die rykste skole in kwintiel 5 lê. En nasionaal bevat elke kwintiel 20% van alle leerders, alhoewel daardie verspreiding nie waar is indien elke provinsie afsonderlik beskou word nie. Die Wes-Kaap, die Vrystaat en Gauteng is op hierdie stadium die provinsies waar dit die beste gaan. En ek was self taamlik geskok. Ek het gedink daar is die bedrag per maand, maar dit is die bedrag per leerder per jaar. Die skole in kwintiel 1, 2 en 3 is dan skole wat volkome deur die staat gesubsidieer word en waar geen fooie van leerders vereis word nie, terwyl skole in kwintiel 4 en 5 wel skoolfonds van ouers of voogde ontvang. So ten einde die skole wat geen skoolfonds ontvang het te vergoed vir verlies aan inkomste, ontvang die skole in kwintiel 1 tot 3 nou 'n groter jaarlikse subsidie per jaar of per leerder per jaar. Die sirkeldiagram hier aan die linkerkant toon die persentasie leerders wie se ouers volgens die General Household Survey van 2019 in staat was om tot skoolfonds by te dra. Die COVID-19 pandemie het egter 'n rampspoedige effek op die kwintielrangorde stelsel tot gevolg gehad aangesien baie ouers of voogde hulle bron van inkomste in hierdie tyd verloor het. En die departement is bekommerd dat die kwintiel 4 skole sal aansoek doen om as kwintiel 3 skole geherklassifiseer word, gegee die haaglike ekonomiese situasie in die land. En 'n goeie aanduiding van die ekonomiese uitdagings kan waargeneem word in die verhoogde versoek van privaat skole vir befondsing. En die probleem is die minagting van daai versoek kan lei tot 'n oorloop van leerders van die privaat skole na die publieke skole. En op hierdie stadium, veral in die Wes-Kaap, het ons nie die kapasiteit om al daai leerders in staatsskole te akkommodeer nie. Nou, net gou 'n bietjie konteks oor hoe lyk hierdie onderwysstelsel gelyk voor die pandemie ons getref het. In Suid-Afrika belê sedert die afskaffing van apartheid 'n groot deel van die nasionale begroting in die onderwysstelsel, maar die kwaliteit en uitset van onderwysinstellings weerspieël egter nie die belegging wat gemaak is nie. En ten spyte van die toename in kapitaal wat in die onderwys belê word, presteer Suid-Afrika se leerders nog steeds van die swakste ter wêreld. Nou daar's 3 internasionale toetse waaraan Suid-Afrika deelneem en hierdie toetse stel analiste dan daartoe in staat om Suid-Afrikaanse leerders se akademiese vordering te monitor, maar ook om Suid-Afrika se leerderprestasies met ander lande te vergelyk. Nou, die eerste studie waarna ek gaan verwys is die Suid- en Oos-Afrika Konsortium vir die monitering van onderwyskwaliteit, of die akronieme SACMEC, en hulle monitor die wiskunde en leesvaardighede van graad 6 leerders en hulle onderwysers, ekskuus. Suid-Afrika het deelgeneem aan die 2de, die 3de en die 5de ronde en 79% van die graad 6 wiskunde onderwysers kon nie in SACMEC se 3de ronde in toetse 'n gemiddeld van 60% behaal op 'n reeks vrae wat op graad 6 en 7 standaard is nie. Dit verduidelik die swak leerderprestasies aangesien 'n onderwyser nie kan kennis oordra waar hulle self nie beskik nie. Die vordering in internasionale leesgeletterdheidstudie, of soos ons dit ken as PILS, assesseer die leesvaardighede van leerders in graad 4 op 'n 5-jaarlikse interval sedert 2001. En die PILS 2016 se uitslae het getoon dat 78% van Suid-Afrikaanse leerders in graad 4 nie met begrip kan lees en inligting uit 'n teks kan verkry om eenvoudige vrae te beantwoord nie. Internasionaal val slegs 4% van leerders in hierdie kategorie. En die land se swak leeruitkomste is 'n binnende beperking in die departement se doelwit om kwaliteit onderwys aan elke leerder in Suid-Afrika te verskaf, aangesien leerders wat nie kan lees nie, ook nie kan leer nie. Die TIMS of die Tendens in Internasionale Wiskunde en Wetenskapstudie word gebruik om die wiskunde en wetenskapkennis van leerders in graad 9 in verskeie lande reg oor die wêreld op 'n 4-jaarlikse basis vanaf 1995 te evalueer. Nou net as 'n tikkie hoop het Suid-Afrika se graad 9 leerders die grootste verbetering getoon in wiskunde en wetenskapprestasie uit die 25 lande wat aan beide TIMS 2003 en TIMS 2015 deelgeneem het. Maar hierdie uitslae was wel vanuit 'n baie lae vlak en ons sal daai kwintiel 1 en 3 skole sal moet versnel in daai vordering om aan die sosiale en ekonomiese behoeftes van die toekoms te voldoen. Ten spyte van hierdie vordering het Suid-Afrika steeds een van die 5 lande gevorm wat die swakste in hierdie toets presteer het, saam met Botswana, Jordanië, Marokko en Saudi-Arabië. In 2019 het ons toe ons graad 5 groep ook ingegooi in hierdie studie en toe het ons agtergekom dat slegs 37% van daai groep basiese wiskundevaardighede gehad het en 28% 'n basiese wetenskapkennis. Die mees kommerwekkende faktor is dat Suid-Afrika se prestasies steeds ongelyk en sosiaal gegradeer word. Prestasiegapings word gekoppel aan die sosio-ekonomiese agtergrond, ligging, ons geen fooi skole, wat staan teenoor skole wat wel skoolfonds ontvang, en dan die provinsie waarna 'n leerder skool gaan. En toe tref die pandemie 'n reeds wankelrige onderwysstelsel, met die gevolg dat leerders en onderwysers amper oornag in 'n onderwysmodel forceer is waar geen stelsel nog ontwikkel of geïmplementeer is om onderwysers en leerders te ondersteun nie. Alle belanghebbendes in die onderwysstelsel moes met die aankondiging van die inperking spoedig beleidsmaatreëls implementeer om te verseker dat leer steeds by die huis plaasvind. Aanlyn onderrig in die konteks van die pandemie is egter nie haalbaar of regverdig in ontwikkelende lande nie, aangesien baie leerders nie toegang gehad het tot die nodige hulpbronne nie. Die General Household Survey van 2019 het gewys dat nasionaal het net 57,5% leerders in die ouderdomsgroep 5 tot 24 toegang gehad tot 'n selfoon en 32% het 'n rekenaar besit om hulle met aanlyn leer te ondersteun. Maar die opvoedkunde-ekonoom Servaas van 'n Berg en Nicholas Spel het egter beweer dat onderrig wat deur mobiele en digitale toestelle ontvang is, gelykstaande was aan ongeveer 5% kontakonderrigtyd. Bewyse dui ook sterkte op dat leerverlies altyd die aantal akademiese dae verloor oorskry en die rede daarvoor is omdat leer nie lineêr is nie. So leerders onthou of begryp nie alles ten volle wanneer dit aanvanklik vir hulle geleer word nie, selfs al is onderrig onderbroke. Die Wêreldbankmodel vir die berekening van leerverlies toon aan dat Suid-Afrikaanse leerders 'n leerverlies van 25% meer sal wees as die werklike skooldae wat verloor is. Nou daar was 93 skooldae vanaf 15 Februarie 2021, die begin van die eerste kwartaal tot en met 30 Junie 2021. So indien leerders in daardie tydperk 'n rotasierooster by die skool gevolg het, impliseer dit dat hulle 50% van hulle akademiese kontaktyd verlore gegaan het. En dan vooruitskattings met daai 25% leerverlies toon aan dat akademiese kontaktyd vir laerskoolleerders 'n leerverlies van 70% tot 'n volle jaar tot gevolg gehad het. Nou, saam met dit is baie van die kinders in ons land afhanklik van skole vir ten minste een voedsame maaltyd per dag. En in 2020 het 8 uit elke 10 leerders op 'n daaglikse basis staatgemaak op 'n gratis maaltyd wat hulle by die skool ontvang. En die sluiting van skole in 2020 en die verlies aan inkomste in baie huishoudings het baie leerders honger gelaat wat natuurlik oor leerverlies vererger het. Nou die ripple effek van die pandemie gaan nog 'n geruime tyd met ons wees en die volle impak op leerders se akademiese, fisiese en emosionele welstand sal met verloop van tyd nog duideliker sigbaar word. Maar daar het wel ook onverwagse positiewe gevolge uit die pandemie gesprei. Nou gedurende die laaste helfte van die 20ste eeu het internasionale denke oor onderwys na 'n nuwe paradigma verskuif. Hierdie verskywing is gedryf deur 'n toenemende bewustheid van sosiale, ekonomiese en tegnologiese verandering en 'n eksponensiële toename in mensekennis wat as gevolg daarvan gegenereer word. En dit het gelei tot vrae oor die rol en doelwitte van onderwysers in 'n wêreld met 'n ongekende mate van kompleksiteit en onsekerheid. Nou in die tye waarin ons leef, is tegnologie sinoniem met toekomsgerigte onderrig. Alhoewel ontwikkelende tegnologie nuwe geleenthede bied vir leer in die 21ste eeu, dui navorsing in skole daarop dat tegnologie nog nie tot 'n revolusie in die klaskamer gelei het nie. Moontlike redes daarvoor is die oneffektiewe benutting van tegnologie in die klaskamer, onderwysers se onvermoë om die voordele van tegnologie in die klaskamer te sien in die konteks van toekomsgerigte leer en die gebrek aan infrastruktuur of die sosiale konteks van 'n skool. Nou die Wêreldbank sien die COVID-19 pandemie as 'n geleentheid om op 'n innoverende wyse die ongelykhede en swak praktyk in die onderwysstelsel teenwoordig voor die pandemie reg te stel. En soos die skoolstelsel stabiliseer, stel die Wêreldbank voor dat daar in die herstelperiode daarop gefokus word om nie die mislukkings van die pre-COVID onderwysstelsel te herhaal nie, maar eerder te bou in 'n verbeterde stelsel met versnelde leer vir alle studente. Nou dit het gelei tot die vraag dat indien 'n skoolmodel ontwikkel word wat voorsiening maak vir tegnologie en e-leer, dit nie die ongelykheid in ons huidige skoolstelsel kan verminder nie. 'n Ondersoek van die skoolmodel voor die pandemie en 'n nuwe skoolmodel wat deur die pandemie aangemoedig is, lei tot die vraag wat hierdie studie sal probeer beantwoord, naamlik wat is die impak van COVID-19 in terme van vooruitgang van hoërskole in die Wes-Kaap? En om hierdie probleemstelling te ondersoek, sal 'n simulasiebenadering gebruik word. Nou, Shabani, die hoërskoolmodel geskep deur van stelseldinamika gebruik te maak vir die vordering van graad 6, 9 en 12 leerders in die Wes-Kaapse onderwysstelsel simuleer. En die doel van hierdie model was om te probeer vasstel watter faktore beïnvloed die akademiese prestasies van leerders en watter faktore kan die prestasiegaping tussen ryker en armer gemeenskappe verklein. Nou die oorsaak-lys-diagram hier aan die linkerkant dui die verband aan tussen 9 endogene en 1 eksogene veranderlike. Daai eksogene veranderlike is hierdie school readiness wat kom van die laerskoolmodel. En die stelsel word gekenmerk deur 3 versterkingslisse en 1 balanseringslys. Die stelsel word dus gedomineer deur versterkingslisse wat eksponensiële groei in die stelsel sal propageer. En die akademiese prestasie is dan die invoer in die voorraad vloeimodel, daar aan die regterkant waarop elke voorraad 'n leerder se akademiese prestasie in een van 4 prestasiekategorieë klassifiseer. Die beperking van die feit dat daar elke van daai voorrade dit in 4 kategorieë verdeel is dat dit die vloei van die stelsel belemmer, aangesien hierdie paradigma fokus op die vloei van homogene kwaliteite. So stelseldinamika is 'n simulasietegniek wat gebruik word om verskillende uitkomste vanuit 'n makroperspektief te ondersoek, deur die simulasie van 'n versameling veranderlikes wat met mekaar in wisselwerking tree oor tyd om 'n eenvormige geheel te vorm. Die beperkings van hierdie paradigma is dat dit 'n bo-na-onder benadering volg wat aanvaar dat hoërskoolleerders homogeen geanalyseer kan word, bloot gebaseer op hulle akademiese prestasies. Stelseldinamika kan dus nie die leerder se vordering meet op grond van verskillende eienskappe nie, maar dit kan wel die krag van die stelsel meet. Nou, om daai homogeniteit probleem van die leerders aan te spreek, het Passerini en Perry die paradigma agentgebaseerde simulasiemodellering ondersoek. En hierdie simulasie-tegniek bestaan uit individuele besluitneming en interaksie-entiteite bekend as agente. Nou, elke agent word gedefinieer met sekere eienskappe en agentgebaseerde modelle is gebaseer op 3 hoofelemente, naamlik die agent se gedrag en eienskappe, metodes van interaksie tussen agente en agentverhoudings en die toestand waarin hulle verkeer, as ook die omgewing waarin die agente bestaan. Nou, Passerini het gekyk na vroeë kindontwikkeling waar sy die kleuters gemodelleer het as agente waar hulle ouderdom, gesinsstruktuur, gesondheidsstatus en die tipe vroeë kind ontwikkelingsprogram waarvoor die kleuter ingeskryf is, hulle vlak van skoolgereedheid bepaal. Nou, AnyLogic is 'n volledige geïntegreerde of het 'n volledige geïntegreerde databasis wat in elke model ingebou is om insetdata te lees en die uitset van die simulasie te skryf. Die waarskynlikhede van die toestande gegee by die eienskappe van die agente word in die databasis gestoor en dan die oorgangsreëls tussen die state is tariewe wat gekies word uit die databasis en is gebaseer op se waarskynlikhede. Die agente sal dan binne in hierdie staatskaart beweeg afhangende van daai waarskynlikhede. Nou, die uitdaging met hierdie paradigma is data. Daar is nie tydsreeks datastelle beskikbaar wat voldoende inligting van kleuters verskaf om vir ons 'n omvattende profiel vir elke agent te skep nie. Nou, Perry het ook 'n agentgebaseerde simulasiemodel ontwikkel wat fokus op die akademiese vordering van graad 1 tot 4 leerders in Suid-Afrika. En die oorlooste doel van die model was om leerders van al 5 kwintiele te simuleer ten einde te probeer vasstel watter faktore is primêr daarvoor verantwoordelik dat leerders in kwintiel 5 skole internasionaal kompeterend is, terwyl kwintiel 1 tot 4 skole se leerders baie swakker presteer as lande met soortgelyke sosiale ekonomiese omstandighede. Nou, Perry kon 'n kind bloot beskryf deur te wys na geslag, familietipe, gesondheid, ouers se opvoeding en die graad wat 'n leerder reeds voltooi het, wat nou nie juist die homogeniteit probleem oplos nie. So die metodologie kan werk as daar genoeg data beskikbaar is. Nou, Ignatius het daarna 'n poging aangewend om data te skep deur simulasie, maar dit het ook nie gewerk nie, want die simulasie-tegniek kon nie die vermiste data bevredigend aanvul nie. Nou, Leighton het toe gegaan en 'n studie gedoen oor die sleuteldatastelle rakende onderwys in Suid-Afrika en haar kritiek op die bruikbaarheid en kwaliteit van elk van die belangrike onderwysdatastelle, die voorstelle vir moontlike modelleringstegnieke wat toegepas kan word op die beskikbare datastelle en voorstelle vir nuwe opnames is handig vir toekomstige navorsing en modellering. Data gaan dus vir my ook 'n probleem wees, maar ek hoop met die nuwe datastelle wat tydens die pandemie beskikbaar gestel is, soos byvoorbeeld die NITSCRAM, wat ander tipe vrae insluit, sal ek wel met publieke datastelle kan regkom, indien nie oorweeg ek 'n gevalle studie met die handige wenke soos in Leighton se studie uiteengesit is. Nou, as die datastel wat in die agentgebaseerde model gebruik word, die Suid-Afrikaanse onderwyslandskap beter verteenwoordig, weens die laer vlak van abstraktheid van die modelleringstegniek, kan die uitset van die agentgebaseerde model gebruik word as 'n inset tot die reeds bestaande hoërskoolsimulasiemodel. Dit sal op sy beurt verseker dat terugvoerlisse in die stelseldinamika model meer akkuraat is, en ons hoop 'n verbeterde finale uitset sal beleidsmakers en die regering kan help om probleemareas binne die holistiese stelsel beter te identifiseer en te help met interventiebeplanning ten einde die akademiese ongelykheid in die onderwysstelsel effektief te verminder.
Questions?
Thank you very much. That was very cool. Mostly depressing, but very interesting. Round in the beginning, you discussed the major budget that the government might have for the education system, and comparing that to Quintile 5 that are doing well within the education system. What do you think is the difference between Quintile 5 and yet the big budget that isn't necessarily doing anything?
I think it's that Quintile 5 schools operate like private schools. They get their money from the parents. So most of the budget goes to the Quintile 1, 2, and 3 schools. And of that budget, almost 70% goes to teacher salaries. So yeah, that is, I hope I answer your question.
So would you say that budget is yet still too small to accommodate Quintile 1, 2, and 3?
Ek dink dit word meer verkeerd bestuur. As ons kyk, in ons begroting gaan daar 'n enorme bedrag aan onderwys. En die hoër onderwys en opleiding ontvang ek dink iets soos 28%. En die res gaan alles na die basiese onderwysdepartement toe, so met ander woorde die skoolstelsel. So ek dink dit word met meer oneffektief bestuur.
The questions? Ek het een. Dink jy van die skole wat nou na byvoorbeeld Quintile 3 toe geskuif het, dink jy hulle sal weer terugskuif of gaan hulle net gemaklik raak met die geld wat hulle nou kan kry of?
Kyk, as ek nou reg onthou, die Quintile 1 tot 3 skole kry dieselfde bedrag. Ek dink die tragiese deel is die feit dat geen Quintile 1 tot 3 skool kon dit ook reg kry om na 'n Quintile 4 skool te verbeter nie. Maar daai werk soos 'n uitruilingsstelsel. So as 'n Quintile 3 skool opskuif, moet 'n Quintile 4 skool afskuif. So daai hoeveelheid bly vas. So ek dink dis maar 'n al ewige stryd dat skole doen aansoek daarvoor om meer geld van die staat te ontvang, maar daar is net 'n seker, ja, daar is net 'n seker
games for money.
ja.
Al jou ervaring. Ek weet 'n mens moet tegniese algemene oplossing toepas met nou al daai faktore, maar indien jy een faktor sou kon kies oor wat ons nou op moet fokus, met al jou ervaring, wat sou jy sê?
Ek wat vir my dit daar moeilik maak is ek het net ervaring van Quintile 5 skole. En dit is 2 totaal verskillende onderwysstelsels basies. Jy kan nie die twee met mekaar vergelyk nie. Ek dink ek het Viljoen gesê ek weet nie of julle Anet se praatjie bygewoon het nie. Ek dink wat my bekommer is die feit dat ek het gedink hierdie wat ons video's maak en dit uitstuur beteken is vir alle kinders beskikbaar. Maar ek het besef ons gaan baie mooi met kyk hoe ons, want om dit net beskikbaar te stel is ook nie die oplossing nie. So my gevoel is COVID het wel impak gehad dat jou goeie onderwysers nie meer net in sekere skole vasgevang is nie, dat daai kennis kan uitkom by armer skole. Maar die vraag is hoe gaan ons dit effektief aanwend? Want om net materiaal te skep en dit net te gee is ook nie noodwendig 'n oplossing nie. Maar om jou vraag te beantwoord, ons werk met 2 totaal verskillende onderwysstelsels.
Kan ek aansluit op haar? Ja, ek dink ons grootste probleem is wat ons elke keer oor en oor vind is jy het verskillende beleide vir verskillende groepe nodig. En wat laat dit jou aandink? 'n land wat nou net as 'n onderwysstelsel kom. Nou kom ek, jy weet ons groep en ons sê die hele tyd verskillende beleide vir verskillende mense. Ek weet nie hoe om ons resultate te verkoop nie. Ja. So nou doen almal maar alles. Dan kry ek wel roos op my toebroodjies.
Any other questions? Okay, no. Thank you for a very insightful talk. No, I tried.
Adam. Ja, ek se krop is. As al een. Dis wat ek kan lees. Ja, ek van my kant actually.
Vlieg hoor.
Whenever you're ready, you can just take it up with those lines. Marno.
Ek kan nie
Onmiddellik, die triggers gaan onmiddellik. As jy dit sê, en as mense soos ekskuus wat wil jy doen?
measures mechanisms. Ons measure is miskien nou wat mechanisme waar die stelle nie, die selle mechanisme, maar verskillende mense soek op anders.
Ons het wel gesien wat gebeur as daar papers uitkom.
Sal nie, as al een dingetjie was.
Staan hy, seker.
Waar jy lekker speel.
Ek sê dat jy was.
Ja, nee, dat is baie.
Ja, vorige antwoord.
Meer uit jou face. Ja. Wat sien jy? Dis 'n baie betekenis. Dit is klaar.
I was going to start.
It's closed. That's around the house. 1,000 rent.
I think that's a good question.
That's the nice. Like the monetary was this was literally to heat upon.
Yeah.
It's just an app. Has to be just.
Okay, so our last session for last talk, at least for this session, will be from Sunday from the School of Data Science at Stellenbosch University. Take it away.
Thank you for coming. They will be discussing long COVID data science perspective. So I'll run through the introduction down to conclusion. I have avoided mathematics, statistics, but I'll only talk about data science, and this is due to ethical reasons because of. So this work I had collaborators, health sciences colleagues from the school for colleagues from Department of Pathology, for Marita Koje, Theresa Pretorius, and Douglas Kell. And I also have data scientists, Liam, Bruce, all these guys, we all work together to solve the long COVID conundrum. All right. So it's known that COVID left a devastating impact on the world, and millions of people, we lost millions of people died. Several people lost their jobs, their livelihoods, and also it's glaring to us that many people still suffer from debilitating long-term health implications due to COVID. But that being said, people can say that, or we can say that COVID is gone or it's ended, quote, but that is debatable because several people still suffer from the symptoms of long COVID. And that syndrome medically is called post-acute sequel COVID, PASSC, which is otherwise known as long COVID. And in essence, long COVID is the long-term reoccurrence of the symptoms and health challenges associated with COVID-19. So what are these symptoms? The symptoms are chest pains, loss of smell, loss of taste, depression, anxiety, shortness of breath, and kidney problems, chest pain, and the rest. In this work, we consider 12 symptoms. What you have on the screen is 13, but we merged loss of taste and loss of smell together. So there has been no global consensus on the definition of long COVID, its treatment or its diagnosis. You may wonder why, because the severity and the occurrences of these symptoms differ in patients. And so you may have a patient that has maybe shows these symptoms or suffer from chest pain or just slight chest pains, and in other patients you may find them very severe chest pain. And so the essence of this work also is just to see if we can gain more insight into long COVID, and ultimately to hasten the relief of millions of people suffering from long COVID. So, like I said, this is the popular Venn diagram of Andy Conway, and so okay, so it's a multidisciplinary research and comprises of the guys from health sciences, medical school or medicine, mathematics, and computing guys. But like I said, I will not talk about the maths, the statistics, the p-values, the bootstrapping, and the rest. So going to the data exploratory analysis. Now, in the literature and generally, we have few data sets with respect to long COVID because it is still novel in quotes. And so we had to come up with our own online repository named South African Long COVID Registry. And so this, like I said, it's an online repository whereby patients, in quotes, I would say long haulers, because people who suffer from long COVID are called long haulers. So long haulers logging into the platform, they register their comorbidities, their symptoms, and other health-related information like the gender, the weight, height, the severity of their COVID, COVID symptoms, and perhaps cancer-related information. So in all, we had 845 patients, and after cleaning up the data, we had 14 comorbidities. I will show them, and 12 symptoms 12 symptoms. Right. So I've skipped a lot of stuff, but I'll just go to this direct. So we found out that 70% of our female participants had long COVID symptoms, and this is in line with what we observe in the literature. On the right-hand side, we have the long COVID symptoms, like I said, 12 in number: brain fog, forgetfulness, down to kidney problems. All right, and then we have the age versus the long COVID symptoms. Like, so in this case, we found that 76% of the participants were between the age range of 31 to 60, and not like that. Not like if you fall between the age 18 to 20. Not that you are not susceptible to have long COVID, but because of ethical reasons, I won't talk about the correlation and causation aspect of this. Okay. So now, this slide shows the comorbidities versus the long COVID symptoms. Comorbidities, we had 14 in all: high blood pressure, high cholesterol, down to previous stroke and periodontitis. So we found out that majority of the participants or the long haulers had high blood pressure and high cholesterol, and coupled with autoimmune disease. The next slide will show, like it will depict this clearly. And so we have lattice plot. The lattice plot is based on knowledge representation, and this plot was created using the formal concept analysis, using matrices and the rest. But there's no need to go into that. So it's obvious that from this plot, if to read this plot, just read from bottom down, bottom upwards. So we have high blood pressure, and this is just for the high blood pressure, showing the relationship of the high blood pressure comorbidity with other symptoms. And it's from the data set, we found out that majority of the long haulers that had high blood pressure as symptoms have all these other long COVID symptoms, just like you see on the screen: digestive problem, brain fog, kidney problems, and the rest. And so this other slide shows also the high cholesterol relationship with other symptoms. You find out that some are missing here, like the ones not highlighted are missing. So, but the issue with long COVID, I don't want to be caught up, but the main issue is that many of the participants or long haulers had this high blood pressure as a comorbidity. So we just some 2 weeks back, we got ethical clearance to to create a model, an analytical model that can predict the symptoms based on the comorbidities, the comorbidities, the gender, the severity of the COVID symptoms. In all, we had like 29 inputs, features, so to say. So for the predictive model, it's based on deep learning. For now, it's based on deep learning, and which this is a popular model in machine learning for training machine learning models. So I will just, okay, for the input, we have 29 inputs. I just mentioned them. The comorbidities, the severity of the COVID symptoms, the age, database, the age, height. But we believe that playing with feature engineering, we can reduce the inputs to have a better or higher accuracy. So our output in this case remains the 12 symptoms. So in other words, we played with one auth encoding, 1 zeros, to be able to get that output. Now, I will only talk about this slide. This is based on ethical stuff. The medical guys don't really, it's difficult to convince a medical personnel that you have an AI model, because it's like, is it going to replace us? How sure are you that this stuff? So I will only talk about this, just this slide. So we created a model that we played with a deep neural network with 8 hidden layers, and this is on this x-axis we have the number of neurons and the prediction accuracy. So before tuning our model, we had an accuracy of averagely 68%. But on tuning the model, we approximately achieved 88%. But it's still, we in the court, when I say we, I mean the data scientists in this work, we still need to convince the medical guys the need for this model. Because like I said earlier on, it's not just to create a model. Anyone can create a model and it can be published, but how useful will it be? So will they be able to use it? Will they agree to use this model? So, so in conclusion, we have a data-driven system, and you may wonder why this. Like now, with data science can help with the predictive analysis, enhanced predictive analysis for long COVID. Can also help with robust health policy, down to reduce OPEX. Also create fast and agile system, like I said, like a model that can help the doctor to know what exact the symptoms may be, because patients they can't always explain their symptoms, but with the model, a doctor can predict, okay, with these comorbidities, these are the likely symptoms that may eventually show up or occur. But because the patient or long haulers may not be able to explain him or herself, so this fast agile systems maybe will come about with the use of data science and also enhance patient experience. Thank you so much.
Excellent talk. You mentioned that you foresee that there will be a problem with take-up of this prediction model, basically. Have you given thought on how to solve this problem? Perhaps, if I can warrant a suggestion, using some kind of very rudimentary F&B, or not F&B, but some kind of app on your phones that you can then just install for these GPs to make it accessible, because I would think that would be the problem. Accessibility.
Yeah, but okay, can I say? All right. it's obvious that in the literature, and I think it was 2 weeks ago, there was a publication in Nature, and it was about long COVID. It was a back and forth discussion on finding solution to the long COVID problem. And some of these authors were mentioned, and the issue is that medical profession, I'm not a medical guy, I'm a data scientist, and so there is no agreement at the moment with respect to the solution to treatment of long COVID. So if they are still at that point, I don't think it's at this moment they find it even difficult to trust models. So they themselves, there's no consensus on treatment of long COVID.
Okay, but that raises another question. There's no consensus yet on what long COVID is. Is this work then not a bit premature, or are you working with biostatisticians, in finding the relationships? Or
Okay, all right. So my collaborators, Theresa Viljoen is the team lead of this work, and Doug, Marita. So they are the best in what they do in the world. And so in that discussion, she made a point and said that that the other scientists should implement our data or implement our own method and see if it works. So it's like, go try my own stuff before you come say that it doesn't work or it won't work. And so for now, it's in quote, it's like the global north and the global south when it comes to long COVID.
so you would say this is an attempt to try and gain an understanding of the drivers for long COVID?
Yes.
Okay.
And so it's part of the work. It's part of providing solution to long COVID. It's just.
Yeah, first of all, I really enjoyed the presentation. I thought it was very interesting. I think it was slide 4 or 5 where you had the ages with regards to the symptoms. I'm not sure if you didn't mention it because of ethical reasons or somewhat, but I found I would assume that the ages like 40 and 30 to 40 and 40 to 50, in comparison to the number of people from the ages 60 to 80 having long COVID symptoms would be less, but it looks more here because that age bracket is more technologically inclined, which would mean they would answer more of your surveys. Have you taken that into consideration?
Yes, yeah. And I also then stated that patients were encouraged to come into the clinic, like 80 thereabout. Blood samples were taken and some other stuff were done. So it's not only just based on the online stuff, but other guidelines.
So in your cohort, everybody would have been exposed to COVID at some point during the
Yeah, it was.
There's been a study that's shown just general random people and the similar symptoms and how their diagnoses have fallen out. I asked just simply because there might actually be a prevailing correlation among high blood pressure with certain symptoms just generally. And that COVID has exacerbated it might be an outcome, but also it might be more.
Yeah. You are right. For now, I don't know of any studies in the literature.
If you have access to the medical records.
I have heard of something. I heard of something that sounds like long COVID for people who have viruses. And it's not something that's been studied before because there wasn't a pandemic. So I think this might be something not specific to COVID, but anecdotal.
Yeah, I'm just to make the difference.
All the patients were tested. All the patients, they are tested to being tested in the course of it. We were so sure they had long COVID.
Other questions? I have another one. Do you think the accuracy of some of these results might be influenced by the fact that the people are capturing their own symptoms and own comorbidities, that some of them don't want to say that they have high blood pressure, for example, and that is missing information in a way?
Oh, okay. You may be right, but if we look at it on the other hand, these patients were not pressured to log in their health record, and it's anonymous. Though, yeah, on the data side, it may not be anonymous. You have to clean out some stuff, but for them it was anonymous, and so they weren't pressured to. So I believe that they should be able to state their health symptoms.
No more questions. There'll be coffee at the conference center, and then the AGM starts at 3:30.
Well, this is-